purpose of the project is to find a water resource to be used in a potash mine that's going to be built about 15 miles west of here. Intera's client will use the water, of course, in the mine process. This is going to be a conventional underground potash mine. They'll bring the ore to the surface, and then they'll use this water to dissolve that potash ore and process it so that they can sell it. This particular location has to do with the fact that we are positioned over what's known as the Capitan Aquifer. The Capitan Formation is actually an ancient Permian tropical reef that formed on the edge of the Delaware Basin, and the Capitan itself is about 1,000 feet thick. We're going to be drilling through that entire 1,000-foot section and completing this well as an open hole producing well, in that we're not going to install casing and screen in the producing interval, but produce right out of the open hole rock. The drilling rig is known as a mud rotary drilling rig. It's the size of the rig is typically used for drilling for oil and gas here in southeastern New Mexico. It has a mast that's 135 feet tall, and this particular rig with that tall mast is called a triple, and that means that it can pull out and put back in 3 joints of drill pipe at a time, and that makes the process go quite fast. This is known as a PACE-on device that is a real-time drilling log of all the drilling activities that are going on up on the rig. So as the rig is drilling, I can look on this screen and see the hole depth, information about the pumps and the amount of drilling mud or fluid that's going through the hole. I can see the rate of penetration, the ROP, and that tells me how fast the drill is penetrating through the formations. And so with that information I can predict when what the schedule might be for the well, as to when we need to have equipment and other support services out here to do casing and cementing and logging and so on. So this is kind of the geologic center here for this project. The diagram in the very back here is a cross-section showing several wells in this region, and it defines what's known as a regional dip, and that allows us to predict from one well to the next what the different depths are to the different formations. This is a lithological log of cuttings that are collected every 10 feet from the well, and they're described and put in that log form so you can see where you are in the formation. These 2 diagrams here on the wall, this is an as-built diagram of the first well we drilled in January and February. This is a proposed design for this well, ICP WSO2. This is a flow chart that gives basically every step that will be used to drill and complete this well. We typically work quite a bit here as we oversee this job site. Up about 6 in the morning, up to the rig, over to the mud logging trailer. Ops call at 8:30 every morning. We'll continue with emails and planning, tracking the progress of the well and communicating with the client. Towards the afternoon, may get a little bit of a rest, but often the work goes right on into the evening. You never know what's going to happen from one time to the next, and you can schedule something ahead of time, but chances are it's not going to happen on schedule. Once we complete this well, we'll be doing an aquifer drawdown and recovery test, which consists of pumping this well and then observing the drawdown in another well that's nearby that we drilled in January and February. And from that we get data that allows us to interpret the hydrogeologic properties of the aquifer and also determine how much water might be produced from these wells ultimately.